Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 2, version 1.6, and we've reached question 9, which reads, a small electrolytic capacitor is marked 100 microfarads, 25 volts. This means that A, the DC voltage plus the peak value of any superimposed AC voltage applied must not exceed 25 volts. B, when charged to 25 volts, it will have a charge of 2,500 coulombs. C, it should not be connected to an AC voltage source of more than 25 volts peak. Or D, the polarity does not matter provided the DC supply is below 25 volts. So why does a capacitor have a maximum voltage rating? Well, let's think about this symbol we draw for a capacitor, which is two plates separated by a gap. And that gap could be a number of things. Commonly for a variable capacitor, maybe that gap is commonly air. So we say the air is the dielectric. For an electrolytic capacitor, it could be something else. It's typically a more complex construction. We can see here we've got between the anode and cathode foils, we've got this tissue material that's been impregnated with an electrolytic solution to form the dielectric between the two plates. And here we can see the insides of a ceramic capacitor where, again, we've got plates either side and we've got a ceramic material acting as a dielectric. Now, any material acting as a dielectric and given a distance between the two plates will be able to withstand a certain voltage. Air, for example, can withstand about 1.1 kilovolt per millimeter. That is to say, if the gap between the two plates is 1 millimeter, that capacitor's maximum voltage rating might be in the region of about 1.1 kilovolts. A larger gap would mean a larger voltage rating. So for a 1 centimeter gap, it might be 11 kilovolts. You can just scale it up because there's more of that air dielectric. So coming back to our question, then let's work through some of these answers. Answer D says the polarity does not matter, provided the DC supply is below 25 volts. However, we are told that this is an electrolytic capacitor, which is polarized because of the construction. There is an anode and a cathode, so the polarity does matter, and it does matter no matter what the voltage you put in is. So let's scrub out answer D. Answer C says it should not be connected to an AC voltage source of more than 25 volts peak. And that looks like it could be the right answer, right? Because if we see a voltage of more than 25 volts peak, there is a chance that whatever dielectric is between the two plates in our capacitor may start to break down, and it would then fail to be a capacitor. So that seems like it could be a correct answer. Answer B says when charged to 25 volts, it will have a charge of 2,500 coulombs. Well, we can quickly check that actually, because we are given the formula which ties together charge, voltage and capacitance in the EX309. So if we plug in 2,500 coulombs divided by 25 volts, we get a value of 100 for C. But that's actually 100 farads. We're told it's a 100 microfarad capacitor. So we can scrub that answer out. Answer A says the DC voltage plus the peak value of any superimposed AC voltage applied must not exceed 25 volts. And that looks like it could also be correct. And in fact, both of these answers are saying we should not be putting more than 25 volts peak across that capacitor. However, I'm going to go with answer A because there are certain conditions where you might have an AC signal that has a DC offset. So let's imagine we have an AC signal that has a peak of 25 volts and that is offset by a DC voltage of 10 volts. And so when the AC is at a low level, the AC plus the DC offset will be below that 25 volt limit. However, when the AC component peaks at 25 volts and we have the DC offset of 10 volts, then the total voltage across that capacitor would exceed the 25 volts maximum, and that may cause that capacitor to fail. So I'm going to go for answer A here. The DC voltage plus the peak value of any superimposed AC voltage applied must not exceed 25 volts. If we skip down to the answers, we can see that for question 9, the answer is in fact A. So when we're selecting capacitors or the maximum voltage rating of a capacitor, we have to think about not only the peak of the AC signal, but any DC offset as well. Thank you very much. I'll catch you for the next one.